everyone. I'm Dickon Ross, Editor-in-Chief of Engineering and Technology magazine. I'm here to host this fascinating Birmingham Tech Week panel on the industry, what is sometimes called the Industry 4.0, what is sometimes called the Industrial Internet of Things. Call it what you will. It's an exciting new area that's going to change more than perhaps most people realize. I remember, it reminds me of the early, when we talk about the Internet of Things, it reminds me of the early days of the Internet, when to try and explain to people who weren't in that technology area what it meant, you would try and find a kind of something that people could relate to, like, well, imagine you'd be able to go online and shop, buy something, or send someone a message or so on. And people would think, well, that's interesting, but many people would be underwhelmed by it because perhaps it wasn't, they'd say, well, I can ring up and order something now. It's not that big a deal. And of course, to try and get across what it would mean was nearly impossible, because you were trying to explain what yet to be imagined, and think now we use the internet for things that even Tim Berners-Lee did not imagine all that time ago. And it feels a bit like that with the Internet of Things at the moment. The way it's used to explain it to people is often people take a consumer example, so you can perhaps change your central heating remotely, or do something with your house when you're out, or so on. So, but they may be true, but they're quite trivial examples. But of course, people can relate to things that are consumer related. But here today, I want to try and perhaps get across that the really exciting things, the really big impact that Internet of Things is having, and it's having first, is in the more industrial area, behind the scenes. So that's what we're going to discuss today. And to discuss it, I have 4 panelists, and I'll let them introduce themselves before I start off on that path of the first questions. So I'm going to start with Laurie. Laurie, will you please introduce yourself?
Hi, good afternoon all. I'm Laurie Liu. I'm digital manufacturing team lead for 2 UK facilities in Rolls-Royce. My responsibility is to ensure we have a capable shop floor digital system and drive digital transformation for the facilities, and also to make sure we use data, we use facts to drive the business rather than use opinion. Thank you.
Thank you very much, Laurie. Next, we have Nisha Mistry from Gambika.
Good afternoon, everyone. My name is Nisha Mistry. I'm the sector head for industrial automation at Gambika. And Gambika, we're the trade association for instrumentation, control, automation, laboratory technology in the UK. We represent about more than 200 companies, and my division would be industrial automation, so representing more discrete manufacturing, drives, control automation, switchgear, that sort of thing.
Thank you. And next I've got on my list, I've got Julian Ware, ABB.
Good afternoon, everybody. My name is Julian Ware. I'm the UK and Ireland sales manager for ABB Robotics. Here today to discuss with you, what's happening in the world of robotics and industrial automation, and those solutions we offer around that Industry 4.0, and give my opinions on that. Thank you.
Thanks, Julian. And Dr. Robbie Balcom.
Hi, everyone. Thank you, Dickon. So my name is Robbie Balcom. I work at a company called Comsol. We provide simulation software. And although we're not directly involved with industrial manufacturing, the software that we provide is used extensively in developing the technology that's used in kind of modern industrial manufacturing processes.
Thank you. And finally, we've got Nicola Campagna.
Thank you, Dickon. Hello, everybody. I'm Nicola Campagna. I'm from Comau, and I'm a digital product owner. So in my department, we provide software for helping the industries to digitalize the production lines and production processes.
Thank you very much. And that's our panel for today. Thank you, everyone, for coming. And thank you at home for watching. So we're going to take questions where we can on the chat function. So if you have any questions for our panel, please put them on the Zoom webinar chat, and I'm keeping an eye on it here, and I will put them to the panel after I've asked a few starter questions. And I'm going to start by asking what is the cutting edge now of the implementation of Internet of Things in industrial processes of the factories, or if you want to call it Industry 4.0, I don't know, whatever term you prefer to use. What do you see going on around you that you've seen recently? You think that's kind of where we are now, but it's dramatically different from a few years ago. And I'm going to start with Laurie, if that's okay.
Yes. So as I base in the shop floor, I actually I see how we transfer from a traditional factory, like using papers, and now we're using digital tools. We use manufacturing execution system, and then link data to business intelligence tools. And now they're no longer the business is no longer using whiteboard or paper to count and to check the performance or throughput of the shop floor. Now we use digital dashboard, and then all the data is real-time live, so that really enable the business to make better and faster decision. So that is all because of Internet of Things. We create those connectivity to get data and then flow into database and then extract the data to the business intelligence reporting tool. So that is one example I personally feel that is completely different compared to 2-3 years ago.
So what does this allow you to do, Laurie, that you couldn't do, that's different from before? Is it, do you make the things more quickly? Are you more flexible? What's changed?
Yeah, so in the past, before manufacturing execution system being implemented in the facility, for example, then to understand how many parts has been made in a certain shift, certain cell, then the production leader will need to basically count manually or rely on operator to report how many part has been made. And then now those non-value added tasks can be eliminated. So everyone will just can focus on more like value added tasks like training, upgrade the skill set of shop floor workers, and because all the data is all in place, real time in one place through the digital dashboard. So that's how what enable people to work on value added tasks.
So, and Nikesh, what do you see as the cutting edge at the moment?
So I think it's a very interesting phrase, like you started with. You said, you know, whatever phrase you'd like to use for it, the actual industry for itself. You know, people throw terms like digitalization, Industry 4, Internet of Things is a phrase. It's an umbrella. These are all umbrella terms that encompass an idea of productivity. I like to see it as an increase in productivity. You know, the aim of all of these things is to improve that efficiency and productivity factors of it. So what I would see the cutting edge at the moment is, ironically, with the current situation that we're in, the current climate, what we couldn't do before, or what we're being forced to do, is do things while we're not actually there. So this whole idea of remote maintenance, remote technology, it's the same as what you mentioned in our household. You know, we can see who's at our doorbell from our mobile phone with things like that. You know, we can do that. And it's the same in industry, being able to control our machines, dial into the machines from our homes when we need to remotely, whether it's in Europe or whether it's, you know, somewhere else in the UK or even down the road that we can't visit anymore. I think the idea, the cutting edge, is being able to do things that we can't physically be there in person, but we can be there now. With this whole meeting itself is one example. But yeah, that's what.
It's as much about control as automation.
That's it, exactly. You know, you can be able to control these things from a remote area, and embedded control systems are the way, you know, that we're actually heading towards, and it's brilliant.
Okay, Julian, on the robotics side,
Yeah, it's quite interesting. It's great to hear Laurie's story, to be honest, when she's talking about that MES layer, because I think some of the big changes we've seen is that real-time data that means we can make real-time decisions. So if we've got an automation system, for example, that's got a robot on it, and there's something happening with that robot or the automation system, maybe there's a fault that's occurring, we can make real-time decisions, i.e. we can say, okay, we know that there's an issue, but if we slowed the line down by 20%, that means we're not going to stop, but we can continue producing. But because if we continue producing at 100%, maybe that's going to mean we have a maintenance failure that means the line's going to stop. So I think that real-time information gives us all of those clues. And I think that's some of the great things we've seen over the last few years, that real-time, the use of the data, but then also that the AI piece, the looking at that data and working out what you're going to do with it. Like within robotics, maybe like I'm describing, that you're looking at the lifetime of a gearbox on an axis of a robot, and you say, well, do you know what? If we continue working the product this hard, the asset this hard, we're going to have an issue in this week, next month, next month, in the next quarter. But if we reduce the output of it, we can get some better efficiencies. And I think that's the sort of things we've seen. I do think there's probably we've still got some adoption issues within the industry, but I think we can perhaps, talk about that a little bit later on.
Okay, so it's about efficiency, but of course, when we say efficiency, so if there's a motor you can spot that it's about to fail earlier than you would have done before, and therefore you can prevent disasters or prevent downtime and avoid all those things, which is about efficiency, but it's also about it's better for use of resources and so on, and the environment. I mean, you can be more efficient in terms of energy use and so on, can you?
Well, that's exactly it. That whole piece that Laurie was talking about, where you're looking at OEE and overall equipment efficiency to see how well your line's working, to see your throughput, how many good parts, how many bad parts. But exactly that, how much energy I'm using. Maybe if you've got a lights out operation, you can take some advantage of some lower tariffs, but you can't make those decisions unless you have that data to hand and you've got historical data, so that if you run one product, it uses more energy, it uses more parts, etc. Maybe it's part starvation, all of that piece. I think with the Internet of Things, that's where it really enables you to manufacture smarter.
So I'm beginning to see now what some of the exciting opportunities and the things that are possible, but that's the next question, so I'll come back to that. Yeah. Okay, and Nicola.
Yes, I agree with Julian and Laurie, but also with Nikesh. They already said more or less what they think, what is the cutting edge of this kind of industry 4.0 or whatever you can call it. And another important thing, in my opinion, is that now you have the potential to read all the data simultaneously from a lot of number of stations. So maybe before you were able to analyze one station at a time, so you find maybe some problem in one station, then okay, this is a problem, but let's see, this is a problem of the station itself, or this is a problem that depends on another station. And so then you have to check another station, and the time to do this is not so easy to manage, and also there are a lot of time losses. Instead, today, with the potential of software and collect the data simultaneously, with just let's say one click on a computer, you can be able to see all the station together, all the data coming from the station, and you can analyze just looking at the graphs or looking at the data, if some problems of some station depends from other station or depends from the station itself. So what I want to highlight here is that data is driving a lot this kind of digitalization in the industry world.
Okay, thank you. And Robbie, what's your take on it?
So I can't give kind of specific cases. I can just really comment more on the sort of general trends that I've observed, maybe from from afar, and I think probably I'll be repeating some of the things that have been said already. And it seems as though the state of the art and the direction of travel is really towards kind of automation, and creating systems which are automated, which are kind of self-monitoring and able to kind of self-correct. So you've kind of got the AI element in there as well, where you're using kind of artificial intelligence to kind of monitor the data in real time and make corrective action based on the data that it's monitoring. But as well as this kind of automation, self-monitoring and self-correcting, which I guess is intended to kind of remove the human element almost from the industrial manufacturing processes. In parallel, we're also seeing in the kind of software world that digital twins are also becoming something that's very much kind of the state of the art, where you will have a manufacturing process, and then you will have a simulation of that kind of manufacturing process, a kind of digital replica of that process that's kind of running in parallel. And the simulation allows you to kind of probe more information because you can get an entire picture of what's happening throughout the whole system kind of non-invasively, rather than just knowing what's happening maybe where you've got your sensors. So you can access a larger amount of information from this digital twin. And in order to kind of get this digital twin, replicating the real system accurately, you can also be feeding information from the real process to the digital process in kind of real time. I mean, I'm not sure that we're quite there yet, but that seems to be the way things are moving, in this kind of idea of digital twins certainly seems to be one that's very much kind of at the forefront at the moment.
Okay, and you're talking about a digital twin for a production plant, yeah? Is that right? Because you can also have them for products, but maybe we'll come to that next.
Yeah. So they come in, in all different kind of shapes and sizes. I guess in a general sense, digital twin would just refer to a kind of digital replica of a real product, or it could also be a manufacturing process in certain circumstances as well.
Yeah. Okay, and I mean, yeah. So. Right, so that's an overview of where we are at the moment, which is already dramatically different from several years ago. So where are we going with this? I mean, I can immediately start to see, some of the exciting opportunities. If you can maintain plants and change the settings and things remotely, well, you could also change them to make a slightly different variation in the product, perhaps, or you could. I begin to see all sorts of ways that directions in which this technology could go. So, so where are we going with this? What's the vision? And is it customization? Is it something much more environmentally friendly than we have at the moment? Well, what are the possibilities here? And I'll start with Julian, if I may. What do you?
Yeah, well, it's quite interesting. Some great topics and answers from the rest of the panel, to be honest, and it really sets you thinking. But I think from an automation point of view, I think where we need to go is this point where, and I still think we're some distance away, is that deep learning AI piece where maybe, I'm not saying the Skynet scenario, but where the automation systems are all making decisions for you. So that scenario I was talking about, where the plant there's an issue with a motor, that means you might need to slow the plant down. But if you could have some industrial automation systems that then start to look at historical information, and they make their decisions based upon what has happened in history, and make some smart decisions on what to do, whether it's, do you know what, this time last year we had a run on product X, let's steer from product X, or from product Y to product X, and change our batch of what we're making. So I think that's where we need to go, this thing where we're reliant on some of the technology to understand itself. Because at the end of the day, what I always say, I heard a great quote that the data itself has no value. It's the analysis of the data that actually creates the value. And I think that's what it's all about. But because we've had Ethernet for many, many, many years, and all of these bits and bytes of data have been traveling down an Ethernet cable for a long time. The amount of data has increased for sure, but now we're starting to understand and analyze that data and know what to do with it. But I still think we've got a lot to do.
Right. So the data's coming in, but it's not being used as much as it ought to be at the moment.
Exactly.
So
there's plenty of data there. Let's choose what we do with it. Let's choose what we do with it. You know, it's the same as Nikesh talked about, you know, your Ring doorbell. You know, how many of us have got one of those Ring doorbells? It goes off probably 75% of the time. We don't even look at it because we know it's a nuisance caller, or it's somebody just walked by the door, because it's, you know, it's that piece. So we're making our own decisions based upon that. But the data's all there, and it's processing it all the time and sending it to my device. I'm just doing nothing with it because I've chosen not to do something with it. So I think that AI piece has got to make some of those smart decisions that I made to say, do you know what, that is something that's safe to happen. This is a process that isn't a problem. Let's carry on doing what I was doing.
Yeah. Nikesh, what's your vision for the future?
Yes, that's some really good answer there, Julian, because I think that's exactly it. The idea of we've had this set of data for a very long time. You know, where we're going with it is to be able to use it, the right ways to analyze it, the right ways to start. You know, you've got preventative and predictive maintenance. You know, these things are just ways of using the data. You know, like you said before, that you can, with a drive, you can see that it's going to, you know, start to wear before it actually wears, and that's just using the data that was already there. You know, I think a good example of that was how Amazon became so big. You know, they had been collecting consumer data for years before he decided to say, oh, hang on a minute, let's use this to look at how we actually show different adverts to people. And it was brilliant, and it's changed the way consumers buy things forever. And it's the same in our factories. You know, I think being able to sort of do this mass customization, you know, able to really change the ways we're using things is fantastic. And it's not an idea of reinventing the wheel. You know, nobody has to come in and do new things and make brand new inventions. They're already existent. So I think, you know, it's very interesting. And, you know, we've got targets, like you mentioned, net zero. But one of the key things that manufacturers that I've seen, you know, amongst our membership, one of the most brilliant things that British industries managed to do at the moment was the ventilator challenge. You know, many manufacturers that within our industry and our lab members had to switch what they were doing in recent times and start manufacturing ventilators because of the need for them. And all they would have to do is slightly change their processes. For those who were a little bit along the way, it was easier for them to do. And some of them realized, you know, that they can use these technologies further down the line when it comes back to doing their own products. So, you know, it was a really good, you know, learning curve for many.
Yeah. Okay. I mean, you mentioned mass customization though. Is that where this is going? Are people going to have it? You know, it won't be just any color as long as it's black. It's any color as long as you like, and different shape and.
Well, that's it. That's it. I think you're quoting Henry Ford there, if I'm not wrong. You know, you can have any car that you like as long as it's black. And you know, mass customization is really the way that will help efficiency. You know, a lot of plants will be able to produce at a lot faster rate if they are considering mass customization options. And you know, the irony is the consumer wants the world on a stick. You know, we are like that. We sit there, and now because of the internet, we want this and this, and we want to be able to customize our products. And if the manufacturing plants are made for this setup, it's going to change everything. It's going to be exactly what the consumer wants.
Yeah. Nicola, what do you see the future holds for the factory?
Yeah, I really agree with Nikesh and Julian. They gave us a really good answer of what the future will be. I want to add one thing about maintenance. One of the field that can really gain value from the data is actually the maintenance, because right now, without data or without analyzing data, the maintenance is done just calculating on time. But the time of what? If you don't collect the time, that you really are using the machines. It's just a time like 6 months. Okay, but maybe in those 6 months you didn't use the machine at 100%. Maybe you used it at 50% or 60% because of some reason. For example, let's say a lockdown or like a COVID-19 coming, the production stopped. But you, with the TBM maintenance, you will count this month as you use the machine. Instead, using the data, you can schedule the maintenance operation, not relying on the time, but relying on the actual data that are coming from the machine. So you can schedule some some maintenance, sorry, after analyzing the data coming from the machine. Or maybe you can also implement some machine learning algorithms that are able to predict when some kind of component will be broken, or something like this. So the software and the system that is in charge of analyzing this data can send you, for example, a notification, even an email, or even on WhatsApp, just saying, "Hey, you have some problem in the line. Just check it." Or, "Hey, if you continue like that, like Julian says before, you will break the component in 1 month, for example." So I think this is where we are going, collecting the data. And as I already said before, since data, in my opinion, are what is driving this change. And of course, as Julian and also Nikesh said, the data have to be analyzed in a right way, and you have to know what you have to analyze. This data can give a real added value.
Yeah, so it's big data applied, mixing with the Internet of Things, which gives us kind of, the application of artificial intelligence to deal with that big data and to learn from it, and to discover things we wouldn't have otherwise discovered. And perhaps that, we're seeing that more and more in the Internet of Things. And I've even heard people start, instead of talking about the Internet of Things, talking about the intelligence of things, is what the IoT stands for. So it's fascinating. Okay, and Robbie.
Thank you. So, I mean, I guess to add to what's already been said, I fear I might kind of be repeating some of the things that have kind of been mentioned already. I guess the hope would be that we can utilize the technology to improve, the processes, to optimize the processes, to minimize the waste, and also to minimize the downtime, so that we can identify, when things are going to go wrong before they go wrong, and we can address these things without having to kind of shut down the process and stop the production line and that kind of thing. But perhaps also we might see that the industrial kind of manufacturing processes themselves might change. So we might see that things like additive manufacturing might start to replace more kind of traditional manufacturing processes. We're talking about customization, and I would expect that if you wanted to produce, customized parts, that using something like an additive manufacturing process or 3D printing type process, it would be much easier and give you much kind of more breadth to kind of go down that avenue of customization. If you just have to kind of provide a geometry and then print it using a kind of additive manufacturing process. So the technology itself may kind of drive us into kind of new and different methods of actually manufacturing, as well as affecting the kind of traditional and improving the traditional manufacturing processes.
Yeah, because the data and the control element and the remote control, the data, all those allow us to start thinking about different kinds of production, different kinds of automation, different kinds of machines. And additive manufacturing is just potentially one of those. That's what we often refer to by the public as in more mainstream media as 3D printing, but engineers tend to call it additive manufacturing, which is probably more accurate. Okay, and Laurie, what's your take?
I think I strongly agree with everyone's comment. That's all a good points, and I'd like to add a comment on top of Julian's view. So I strongly agree, like artificial intelligence and deep learning, that will be the enabler to take us to the next level, which at the moment, like we have many companies probably use like execution system or have sensor in their machines, but how to use AI to instruct the user what will be the action out of those data. We have data dashboard showing the Pareto chart, showing what is the highest defect for the certain product. But do we need to change the machine, change the tooling, or is that related to individuals' performance? So those kind of things, AI will be able to like provide an actionable like action for us to improve and then influence the actual production. And also another application for AI would be to replace quite a lot of visual inspection. So a lot of inspection like X-ray require very labor intensive, need inspector to look at the film or image to decide is there any defect. But if we have AI, like we train the software to use supervised learning, and we can first probably make the result more consistent, and second is the efficiency. We can probably process more inspection in the same time frame. So that's my undertake of the future trend, is have AI deep learning to take all our existing technology to next stage, to become a closed loop infrastructure for decision making.
Thank you. We have a question from one of the audience. Jonathan Beebe asks, IoT, many different definitions of what this means. I agree. For me, the internet word indicates an openness and ability to share information between things, parallel with the internet of humans. My question, is there agreement at the semantic level for describing the information being communicated? Or is each installation a proprietary solution which only communicates within the factory where it's used for internal commercial advantage? Are there published open schemas, etc.? Who would like to take that question?
I'll take a quick view on it. To be honest, it's a great question. To be fair, and I think it's a bit like the debate around the connector on the bottom of your mobile telephone. You know, do we use a Lightning connector? Do we use USB? And I think when we talk about the openness, certainly there are some open standards for the communication and how we can communicate with the factory for certain. You know, there's some open protocols. OPC UA is one that I can just name off the top of my head. But I think that's exactly the problem. That because there's so many different communication protocols, it's a bit like how many languages there are in the world. That then having a system that can talk between you know, somewhere in a factory in Rolls-Royce, in Laurie's example, to one of their tier suppliers that are providing with the pieces, is going to be very important. So there are some of those systems that exist, but yeah, it's almost as if, you know, you've got to write a standards document. If you're putting an automation factory together that needs to communicate outside of your building, then almost that you need to put down a translation document that says we're going to be sending these bytes of information, this information, and you know, we require from you like this, and we have to join it together. But I do think that there's probably some, you know, some standards that need to be put in place so as we can do them common things. A lot of it is already done, but I think great question. I think there's some stuff that we can still do around that whole topic.
It's probably perhaps this is one for Nikesh of Gambika. I mean, as an association, you have different, you know, a whole range of members, and I believe there have been different standards floating around in this area. What's your What's your opinion?
Yeah, so it's along those lines. I mean, similar to what Julian said, where it can be opinion within the factory as to what you use. But in terms of the schemes from a trade association point of view, there are many schemes available for you to get involved with. There's the Made Smarter initiative, which is going on in the north with the Northwest Pilot. There's the High Value Manufacturing Catapult. There's KTN Network, which are offering a lot of schemes as well. So there's a lot of different schemes out there which actually you can get involved with, which help you, start you on your journey, which is where most people don't know what to do. It's not about once they're on their journey and continuing it, it's how do you start? And that idea that, is there some sort of standard? The honest answer is no, there isn't. Julian mentioned OPC UA, and that's becoming, a new open source form of architecture, which is much more flexible for people to use. But you'll always have a company that have their own, software that they've written and they're very close to, and that they want to keep using, and they don't want to keep it open. So there is no standard at the moment, but it's about what works best for you. And the schemes that I mentioned help you understand that. So they'll help you use the right technology. It's not, there's all these technologies, you can use any of them. There are certain ones which are right for the right application, and these people will help you find that.
Yeah, I mean, it's pretty crucial as well, being able to talk the same language for the future, because, I mean, even if you take the example of let's say, a car which has a digital twin of its own in the future, and the digital twin shows that something is about to go wrong with a component, and the ability to communicate back down the chain and say, well, this means you're going to have to, to generate the data and it be understood and then implemented in such to alter the production processes or the maintenance procedures or whatever. You need to be talking the same language for all that to be automatic. Yeah, so it's pretty important, I guess. Does anyone else want to comment on this before I move on to the next question? Okay, so the next one I've got is, which is from Kieran to all panelists. With a variety of data that is being generated by devices, are there any specific standards or frameworks in place that are required to be followed when dealing with IoT for industries? I think that's probably what we've just addressed, but if anyone's got a different take on it, that's fine. Otherwise, I mean, standardization by the sounds of it sounds like it's one obstacle at the moment, but it is surmountable. I think the one hears about a few others that are getting this vision we've just described, get in the way of it. Perhaps if I can, if you want people to think about what needs to be done to make that happen. We've talked about standards a bit, but there may be other issues to do with investment decisions, for example, and the economic environment in which we're operating. Laurie, if I could come to you first, perhaps. Sorry to surprise you with that first, but do you see any? What do you think are the obstacles to making this bold new vision a reality in the future?
Yeah, so in terms of standardization, way of make the data can be used in multiple different platforms. I think that is something when the enterprise want to invest the IoT application need to consider first, because without thinking the consequences of implementing multiple different devices and products, and we might not consider how easy we can join them up in the long term. So I think from my experience, my customer in the plant always ask a question about, now, okay, I have MES data in one of the shared business intelligence tool, and then I have enterprise data on SAP system. SAP also have its own business intelligence dashboard, and we also have dimensional data measure in shop floor. So, how can we integrate everything in one place? So I think that is something when we decide or define which spec or standardization way of integrate all the data into one place. So I can't answer very detailed how that will happen.
Yeah.
But I think that is something when we pick up what platform or what device want to use, need to think about long term. How easy to make end user to use it in the one single platform.
Yeah. Okay. So we have the problem, but not necessarily the answer yet.
Yeah.
Julian.
Yeah, I was going to say it's quite interesting when your question as well started around, you know, what's some of the issues that, you know, adopting some of these things as well. And as I see it, we're still stuck in that situation where, you know, we read every day, you know, on the news today, British Airways fined 200 million for a data breach. So I think some of that security piece is some of the piece that's stopping that industrialization moving on. We're all terrified that our data will be, you know, accessed from somewhere else. So, and I'm sure Laurie and her plant in Rolls-Royce has that same fear that, you know, how secure is the data that is inside their plant? Can it be accessed from outside the plant? Even if they've got an MES system that they can you know, view from outside of the plant remotely, how secure is that data? So I think some of the blockers are that security piece and getting the IT team on board. So it's very strange to have conversations. We're used to, as engineers, we have conversation with engineers about engineering things, but these conversations are now moving on to, as we talk about the IoT piece, those conversations are now moving into the IT team, and we have to have you know, sensible conversations with them about how secure the data is, how secure the network is, what we're doing, the patches we're putting in to make it secure, so that they know that if they're going to put an IoT system into their plant, that the devices are safe. You know, the last thing we want to be able to do is have a device that would be hacked by the internet, you know, externally and be, you know, part of some sort of scandal. So I think that security piece is a blocker, and it's something we need to do. And, you know, make security one of the key things, one of the key drivers is we put that security, and defense in depth is, you know, like a common term that people use and that we use.
So far we've got security, we've got standards. Robbie, what do you see as an obstacle to moving forward?
So, I mean, in terms of, I guess, using, you know, simulation to develop things like digital twins, and to use simulation to develop the technology that's kind of at the core at the Internet of Things, I would say that, I mean, the push, I would say, kind of within the sort of computational modeling software sort of realm at the moment is towards this idea of democratization, of trying to kind of, you know, get rid of the barriers that kind of prevent people from using computational modeling. So to make computational modeling more accessible, so that you don't need to have, you know, a science or engineering degree to be able to do computational modeling. And the idea here is really to try and make, you know, simulation software kind of less intimidating and easier to use, so that someone can kind of pick up a piece of modeling software and develop something like a digital twin more easily without having to go through a long process of training and learning how to use a particular kind of software platform. So there's this kind of idea of this kind of democratization and more widespread and pervasive use of kind of simulation software to kind of, you know, promote some of these developments that are needed within the kind of Internet of Things, I guess.
Yeah, I have seen some of that sort of more user-friendly software for building digital twins and things here and there, but you saying it's not as good as it could be? I mean, what we need is something, I guess, like the web browser for the internet, you know?
So at the moment, there's a kind of push towards developing what we call simulation apps. So rather than being a complete kind of simulation platform, what you have is a simulation app that will perform a simulation task. The app has some inputs that an operator will define in terms of some numbers to define maybe operating conditions and geometry. And then all you need to do is kind of hit compute. The simulation will run, and it will provide you, you know, with some results out from that simulation that then you can kind of analyze. So this, the idea is that something like this could be used like any other app on your phone. You don't need to have a background in, computational modeling or anything like that to be able to kind of benefit from the technology.
Yeah. So democratize it and make it as easy as
Yeah.
possible.
Yeah.
Okay, so we've got that and security and Nicola, what have you got anything to add to that list, the growing list of obstacles?
Yeah, I agree with all these obstacles. It's hard for me to find another item to add to this list, but I want to highlight also the standard problem, since right now every customer wants, let's say, IoT, wants data. Every customer wants these new kind of words that can use in its line, let's say. But the problem is that 90% of the time the devices are quite old. So for example, naming OPC UA, maybe those devices are not compatible with OPC UA because they are old, because they are manufactured 15 years ago. So for example, a PLC of the line that is manufactured 15 years ago, when OPC UA didn't exist at all, cannot be compatible with OPC UA, for example. So it's very difficult to find a standard way to collect data, since 90% of the case you are dealing with old devices. And so this is an issue that we are encountering, for example, in Comau with our customers. And every time we are interacting with the customer, at the very first moment, the most important thing that we have to clarify is how to collect the data and which are the protocols that our software can support. And we do a job of looking for a protocol that is compatible for us and also for the customer. And it's not so straightforward. And of course, I agree also with Julian about the cybersecurity problem. In fact, when we are dealing with customer, we always dealing also with ICT departments, both Comau department helping us to understand which kind of things we have to ask to customer ICT department, and also how to let's say train the ICT department of the customer to let them understand which can be the real threats about data breach or data security. Yeah. This is what I see from my point of view, and what we are dealing in Comau.
Okay. And Nikesh, that's quite a long list of obstacles, but there's Gambika with perhaps the broadest view. Is there any other one you'd like to mop up?
Well, I mean, I guess there's a fair few obstacles that different companies face. You know, we speak to lots of different members, and they all have different ones. And everyone here today has touched on a different idea of it. And I think it encompasses this broader idea of a mindset change. You know, ever since, you know, there've been revolutions before, industrial revolutions before, always come with two things. You know, there's a change in innovation, and there's a societal change. You know, you've got an environmental change that everybody has to accept that this is the way it's going forward. You know, anytime innovation sort of forced businesses to make changes, they'll always invest in new technology as a means to adapt the technology, but it's based on yesterday's premises, sort of what Nicola said. You know, these legacy systems, we don't need to throw them all out. And it's that mindset that we might be scared that digitalizing means we have to get rid of the old and in with the new. No, it's not necessarily that case. It's installing a sensor or a monitoring system on your legacy equipment, updating the software, allowing you to use it going forward, which, you know, will provide the building block going forward for the revolution, for the evolution of digitalization era. You know, it's this mindset idea, touching on what Julian said. You know, you've got the IT guys and you've got the OT guys, the operational technology. They never normally have mixed before. Within our membership, they're always two separate departments. And whether it requires an organizational changes to converge the two together, have them work together more often so they understand each other's departments, because they're within the equipment that they buy, they're in one department. So, you know, it's not like they're two different departments anymore. They're almost converging. So it's this mindset idea. And again, it comes down to the return on investment. You know, I think Julian mentioned 200 million cost of security. How do you see that? How do you see that damage? When you're buying a big machine, you can see how much it's going to cost. You know, you've got physical. When it's security breaches, when it's data breaches, that cost to you, you can't see the damage or the effects, and that's the fear. So we need to change that mindset to make people understand better the, you know, the cyber security you can put in to prevent these things, and that it is safer.
Right. I mean, when we talk about changing mindsets as well, I mean, it was mentioned earlier on that one of the reasons for doing this is to take the humans out of the factory, to make it, there's various reasons you want to do that. They're not just cost, they're often to do with efficiency and cleanliness and so on and so forth, depends on the manufacturing. But as representative of Gambika, when people put well, what about the job losses? What about the effect on all the people in the economy? What do you say to them, Nikesh?
Well, one of my most frequently asked questions, if you like, but one of the most hated to answer, because I think would love to answer, but hated to respond, because it's the wrong mindset. I'd say it, you know, in black and white terms. It's not that robots will take all of our jobs. You know, there's a chance to upskill. I think Laurie mentioned you learn. You know, you're always going to need humans. The idea of robots, what they're good at doing is repetitive tasks. They're good at doing things that humans will not be good at doing, because, you know, we get tired. We are humans. But this digitalization era is allowing humans to have more jobs. During this Made Smarter initiative that I mentioned earlier, they're actually keeping case studies of factories where they've digitalized, and it's mainly up north at the moment. But within these factories, there's 50% increase in jobs. You know, companies don't even have data analysts, which they didn't need before. That's one prime example of a job that, you know, is going to be the new future. So it's actually creating jobs. Yes, there will be some lost, as I mentioned, you know, that's inevitable, but there always has been. You know, the steam engine replaced the guy who was controlling the go-kart. You know, it's always going to happen. But, you know, what we're looking at here is not robots taking our jobs. We're looking at how we can work alongside them.
So it's not just the government campaign at the moment to talk about cyber jobs, you know, cyber security, but there are many other categories, new jobs that are going to spring up. Does anyone want to suggest a few? Or
yeah, I would like to. Yeah, I'd like to add a comment. I think that's really good point. People, when they heard of like smart factory, they might think, oh, that it would be no one in the shop floor. However, that's misunderstanding, because robotic doesn't necessarily replace people's job. We just create different type of job, like data scientists and a lot of different analysis. And you have MES engineer, subject matter expert, solution architect. Those jobs probably 10 years ago not have that many vacancy, but I think data scientist, data engineer probably now is on the top 10 job, which has the highest demand due to the industrial revolution. Now we're moving to 4.0.
Yeah, and I'll add something to that. Some great comments from everybody, and I think times where we are now, COVID-19, when we've got social distancing problems, it's a good example where, you know, robotics and automation would come into its fore, because, you know, they don't have to socially distant, so we wouldn't have those issues currently. You know, when you look at the robot density, you know, the IFR measure the robot density per 10,000 people, and the UK is sadly well behind the global average. The global average, I think, is something like 113, and we're sitting at something like 89 just for manufacturing, excluding automotive. You know, countries like France, Slovenia, Czech Republic, all above the UK. Do we see in those countries that, you know, those same questions? No, it's just about automating those jobs, dull, dangerous, dirty, monotonous, and, like Laurie said, giving more value add. Those pieces of equipment still need to be repaired. They don't self-maintain. You know, they still need to be repaired. They still need to be looked after. They still need to be programmed. So we just look for some, some more value add jobs where we're not giving, operatives the jobs that, but perhaps they don't actually want to do. But it's a consequence for the current manufacturing climate.
Yeah. Anybody else want to chip in there? No? Well, I've got to finish soon. So I'm gonna finish by asking, what we started off by talking about how the Internet of Things is not just about gadgets in your home, but I'm interested to know what each of you might think is the thing that consumers will notice. What from all these things that are happening behind the scenes as far as the consumer is concerned, but what will they see that's different? Will they be able to be faster to arrive, or more flexibility, or perhaps something I haven't thought of? Julian, perhaps to start with. I see you nodding. So.
Yeah, a great question, and I think somebody mentioned earlier on, Nicola, I think it was you, when talking about Amazon, or somebody was talking about those sort of e-commerce type deliveries. Now we're all sitting at home. We've been working from home since March, some of us, and those businesses have really boomed. But think about in the background how those businesses operate on minimal staff, so that when I press a button, to order something online, to get that to my home as quick as possible. And that's almost like we talk about that batch size one. That is that where we want just one item, and somewhere in a storehouse somewhere in John Lewis or H&M for clothes, there is sitting hundreds of these items, but I just want one of them. I don't want multiples. So you have to have an automation system that goes and identifies your one product out of 100, in their inventory, puts it in a bag for you, labels it up, gets it to your door, and in some cases, within a few hours. Without an automation process in the background, without the Internet of Things, those things that we now, it's second nature to us when we go on our apps and we order something. It's second nature. And when it doesn't arrive in 3 hours and it's 4 hours, and we're like, well, I paid for it to be here in 3 hours and it didn't arrive. It didn't arrive the next day. Without that Internet of Things, without that automation in the background that really does that really wouldn't happen. So I think people probably see that there's a change, but have forgotten what it was like 5 years ago when you went to order something on the internet, and it might come in 7 days in the regular post, but it wasn't a guy driving up outside our door in a van and putting it on our porch outside.
Yeah, or as in the future it'll be arriving perhaps by drone.
By drone, yeah, exactly, yeah.
As if they can sort out our cities to actually have them anywhere for them to land, or and they imagine the noise. Anyway, Robbie, what do you think it would mean for what will consumer notice is different?
Well, I guess greater choice, when it comes to buying consumer products, and I guess perhaps, greater scope for customization of products that are kind of tailored to you specifically, bespoke options and things like that, potentially.
Okay. Nikesh, what will they see?
Yeah, I would agree with that. I mean, I think the consumers we'll see like more move towards robotic cars, electronic cars, that sort of thing. It looks like in the movies. Maybe, we don't know. We can't see the future, but it's about how we adapt the skill set, how we focus on the younger sets, the primary engineers, the secondary, teach it in schools and upskill so that the future workforce is prepared for what's to come.
And Laurie, what will the consumer notice is different in the future?
Yeah, I think people, like all the panels have probably mentioned most of the point, and like faster delivery and then more choice, and then compared to a couple of years ago, I would say like now mobile phone is really our life. We order food, use mobile phone, we pay parking on the phone, we invest on the phone, we basically do everything. We check bank account. So that is something probably we didn't have that capability like 5 years ago. But now, like if we go out without phone, it kind of you cannot pay, you cannot like do like many things. And going forward, probably like we have electric car, and then they have those self-driven technology, and then it might be in future like taxi will have just no like human being driving. It will be just one of the example we consumer will notice in probably in the next decade, and then using drone to deliver food or in the extreme weather condition, that kind of thing.
Okay. And Nicola, final word from you. I think we've just got time for if you want to.
Yes, I was having the same idea of Laurie about the use of the mobile phone. Maybe, yeah, today we order from Amazon, we check bank accounts, we check everything with our phone. Maybe in the future we also can speak to the machine directly with the phone. For example, giving some commands to the machine, stop it remotely from an app, or I don't know, something like this. This is what I was thinking.
Okay. Thank you very much. That's the final question for today, and it brings us to the end of the session, more or less on time. So thank you everyone for participating. I think that was really fascinating. We covered quite a lot of ground there, and thank you all the viewers for watching. I'm going to sign off now, and have a good Birmingham Tech Week. Thank you everyone.